that as we're going along. Okay.
Okay, welcome to the July 30th, 2024 session of TAPR-HamSCI technical session. My name is Dave, KV0S, and this week I've been working on a few bugs that I have in my radios that I'm trying to figure out. Slowly, step by step, I'm making progress. And I'm also collaborating with um, John Ackerman on supporting his or providing opportunities for his 6 meter beacon. Or actually, he has a 6 meter receiver. So if anybody has capabilities to transmit 6 meter whisper or uh, FST4, those would be great. So anyway, that's where I am now. Next on the list is Nathaniel, W2 NAF. Go ahead, Nathaniel.
Thank you, Dave. I have been busy getting ready for AGU abstract submissions, which are due on Wednesday. I'm working with my students. They're submitting abstracts as well. We're just trying to keep all of the different projects running and still working on revising that GRL manuscript I've been working on. But the good news is I think I now have really good results. So now it's just a matter of properly writing those results up. So it's moving along. Back to net.
Okay, next on the list is Dave, KD0, EAG. Comments?
Oh, hello. What have I been doing? Uh, Messing about, working a bit on schematics and thinking about um, the FPGA approach to multiple ADCs for future use in a receiver. I guess is probably the biggest thing of relevance here. Um, but that's it really pretty much for me. That's back to y'all.
Okay. Next on the list is Dave New, WB8 SBE. Go ahead, Dave.
Okay, it's N8SBE, but that's all
Oh,
right.
sorry.
Yeah, so I was here last week and we had a conversation about the TDOA experiments that were going on, and so I've been trying to just work on getting up to speed on the latest paper and poster that was put out. So that's kind of my interest at the moment. I'm always interested in anything, so
Well, we're glad you're here then.
all right.
Okay. Next on the list, we have Jim, K4BSE. What's going on with Jim?
Good evening. Well, not a whole lot radio related going on here. I've been dealing with the HOA some, not a pleasant thing to do. And did just get back. I don't remember whether it was on last week or not. We just gotten back from uh, sailing down the a European river on a river cruise. So I'm trying to get back in the groove of things. Not doing a whole lot with radio at the moment, though.
Okay. Next on the list is Rob, AI6VN. Rob, you have a few short comments?
Uh, well, you usually leave me to last so that I don't overwhelm the conversation.
Well, you can talk later too.
I will. I plan to talk later too. But basically, I've been working on Whisper Daemon, adding FT4 and FT8 support and uploading to PSK Reporter to it. So all the sites that are running are Whisper Daemon with an RX 888 will now not only gather all the whisper spots and the F4W spots from the whisper bands, but also will be reporting all of the bands, all FT4 and 8 bands to PSK Reporter. So
very good.
That's my major focus, and which point I'm going to stop working on Whisper Demon and do something else.
Well, good luck with that.
Back
So,
to you.
next on the list is Scott Newell. He usually doesn't have a mic. So, yes, well, you're welcome here. And next on the list is Bob in 5VRG. Go ahead, Bob.
Howdy, I spent the past week, adding a couple more cameras for my global meteor network observations, and knocked my network off the air for 2 or 3 days while I was reconfiguring things. But I didn't lose any of my magnetometer data or the 10 megahertz great receiver, and that ought to all be processed and back up. But got everything working again. Anyway, back to you. That's all.
Oh, very good. Next on the list is Clint Turner. You got a comment, Clint?
Oh, you caught me off guard a little bit. Rob and Paul know me for a long time. So does Franco. But the main guy behind the Northern Utah Web SDR, and I'm one of Rob's partners in crimes on and testing things and keeping things going and trying to keep each other on the straight and narrow. But as you probably know, we want to whisper stuff and been involved with propagation, multi-band transmitting for both the October and the April eclipses. So anyway, here for the first time because Rob keeps talking about it.
Well, I'm glad you're here.
Yeah.
So, do you have a comment, Franco?
No, I said, welcome, Clint. I'm glad to see him here.
Yes. Very good. Next on the list is Dave H. W6OQ. Go ahead. Muted.
Yeah. I was trying to use my space bar and somehow it doesn't work all the time. Still trying to figure that out. I'm just here watching, seeing what's going on. Looking at maybe, getting set up to do like receiver performance tests and stuff like that. I've been wanting to do that for a while. Got one generator that's good for that I just got off eBay and tweaked it a little bit, and it seems to be working good. And it looks like I might need another one. Anyway, that's what I'm doing.
Sounds interesting. Next on the list is, let's see, let's call on Gamal. You have any comments, Gamal?
Yeah, thank you. I've just presented that poster last Wednesday at a workshop. Its title is Unifying Innovations in Forecasting Capabilities Workshop, UIFCW. But the most interesting thing that I began to put hands on to receive Whisper, and I found this device. I don't know whether you can see it or not. That's called the USRB device. I found it in the lab in my university. It's NI instrument, NI USRB 2900. The most interesting thing that it receives and transmits at 70 megahertz to 6 gigahertz.
And I've been encouraging you to see if you can't use it in the shortwave bands.
Yeah.
A number of us use that. It will need a different interface card.
Yeah.
For interface cards, but it will with the what they call the standard cards.
I think it's the person who actually like designed that is before my time, but I think it was Matt Edis, and he I think got a lot of his start with the Tapper group. So probably some of the older Tapper members actually know the person who designed that.
Yeah, but the cards are about $200 a piece.
Yeah.
From Edis Research.
Very good. So
seems like a marvelous device. High quality, very, very, very professional. Is that right?
Yeah, that's a $3,000 instrument.
Yeah,
which is what we're trying to replace at a fraction of that.
Yeah.
Yeah. Well, we'll continue down the list. Let's see. Franco's next. Go ahead,
My
Franco.
next.
Yes,
Yeah, good evening,
K4 is
everyone. So,
easy.
what I've been working this last week is playing around with the TRX Duo. I built another image based on Pebble Damming, the one that can do a whisper at the same time. And now I'm building an image based on something called build root. So I'm spending time learning about device trees and things like that. So that's my work for this week. Back to you, Dave.
Okay. Dave McGaw, have I called on you yet? I don't think so.
No, you have not.
Go ahead, Dave.
Good evening, everyone on the net. Number of things. First, I'll point out that we just got a CME coming by, but BC is very positive. So just a little tink to the magnetic field, but God knows what'll happen over time. We've got more coming, and could be an interesting weekend because it's also the peak of a couple of meteor showers. And I'll be out looking at the sky because it's our Stellafane convention this weekend with telescope makers in Springfield, Vermont. And well, may not be seeing the sky. The weather's not looking good. So under these conditions, we call it stellar rain instead of Stellafane. But this is not unusual. Part of the deal. I've also been working on the RX-888 external clock structure, finding it a little bizarre. That first it does not switch the oscillator out of the circuit, though it turns it off. But the yeah, as has been noted, it's not capacitor coupled to the outside, it's capacitor coupled to the 5351. Now I have one that it has been, had a problem. So I had occasion to pull the cover off, which I was going to do anyway. But turns out this particular one, the 5351, is the problem. It appeared to be temperature sensitive. It's actually pressure sensitive. You push down on the chip and it works. So manufacturer problem, and I do notice they are not standard. The mainstream, they're not Silicon Labs or whoever they call themselves now to protect the guilty. It's a off-brand chip, but same function clearly. Anyway, I've getting into that and figuring out how to drive it.
Just a point, the Silicon Labs, they got acquired or sold to somebody else, and there are other legitimate sources of that device out there. There may be a clone too. I'm not sure.
It's the M-Star is the Chinese manufacturer of that same device.
Yeah, that would be what it's in.
That's what's his name is.
I forget if it's MN or MT is the prefix instead of SI on it.
MS.
MS. Yeah. That's what it is.
Mm-hmm.
So anyway, that's what's in there. Yeah, it turns out the input has back-to-back diodes right on it. So as long as you don't overdrive it, or it's fine. But
no, that
you
doesn't.
can blow it out.
You can easily blow it up. I've blew up one that Clint repaired. Clint, do you have you put a blog page together?
Yeah, I have a whole blog page, reverse engineering the problem. You can't even use a transformer to drive the external 5351. You have to put an external capacitor because the copy that I repaired for Rob was DC right to the clock input pin.
Yeah.
That's not
David,
what this one is. This one has a capacitor in the way.
Yeah, David, can you drop a schematic and share that with us?
When
I would really
finish
love to see
figuring out what it's really doing. Yes, I will.
Thank you.
But yeah, this one's got a capacitor to the input of the SI
I'd like
chip
to complete the roll call before we get into discussion.
Trying to think I think I've covered the check-in topics
we can
that
get
I
back
wanted
to these topics.
Very good.
Okay. Next on the list is Gary, AF8A. What you been up to?
Yeah, good evening, everyone. Yeah, I've been trying to get on the air, do a little bit of operating for a change, and taking care of a little bit of HamSCI business in the background. Tonight, if we get to the AGU abstract topic, I've got a question on yet another one, but we'll see when we get there. Back to you, Dave.
Okay. And let's see. Next on the list is Jonathan. And at this point, what have we been up to recently? Jonathan?
Hi, yes. I've been I'm still kind of stumped on the issue with getting kernel PPS working on the Dell Thin client serial port. If anyone has any experience with that, specifically with hardware serial ports and interfacing a PPS, please let me know. I would love some fresh new ideas, a fresh set of eyes. Because normally in that situation, you just pick the serial port and you can see the pulse per second cert and clear messages, but I'm not seeing them. I don't know why. That's kind of what has stumped me. I've also had some hardware failures on the in the home lab. My FreeBSD server, the motherboard, it's been running continuously since 2012, so it looks like the capacitors are failing. So I'm gonna get a replacement motherboard, and I'm gonna replace the capacitors. That's the machine that I do a lot of my VLF signal processing, as well as other general tasks, as a shell server. I upgraded the Lantronix serial terminal box that I had. The one I had was made in 1998. You would basically telnet in, and you would have access to a serial port if you had some sort of serial devices. But anyway, I found the upgraded model. This model supports SSH, and it's been working quite well. So I'm working on getting everything back up and running, and working on the kernel PPS issue. But again, I just want to say that I think the gold standard with these VLF systems will be the Behringer USB audio interfaces. They're really probably the best hardware for this. I didn't realize how good they actually were until I used them. Everybody's been raving about them, and I've been having really good results. So moving forward, I'm going to be using the 2 and 4 channel interfaces. That's all I have. Back to the net.
Okay. Next on the list is Paul Elliott. Go ahead.
Yeah, pardon me, evening, everyone. Yeah, I've been digging into this time of arrival stuff some more. Been talking with Gwen about it and looking at the Ryan Tolboom's text, his blog pages about it, and looking at, well, that was with Whisper, and looking at, sort of as a baseline, what is possible with Whisper? And the answer is, looks like we're on the order of 10 milliseconds, maybe 30 milliseconds without some interpolation or extrapolation and, filtering. So 10 milliseconds Whisper. In the process, discovered some interesting things about what my my Whisper Sonde was doing in terms of transmit timing. It perfectly meets the requirements for Doppler shift measurements and all that, but the start time is kind of within a 30 millisecond window. The start time varies kind of in a sawtooth pattern. And looking back at my code, I can see why it does that. So that was just, it's an interesting anomaly. I may fix it in the next version, or I may not. It doesn't really affect anything we're doing with it, but that was an interesting byproduct of looking into time of arrival of various whisper signals. Other than that, I've been well, let's see, I've shifted my operations from Friday Harbor to Occidental for a few weeks. I'm down here in California now, and I've been working on kind of production ready filters and SDR front end filters and the filter preamp combo. So I'm at the point where if people need more of those, I can deliver at least a few more now and more later. Other than that, not a whole lot, but that's been keeping me really busy. And back to Net.
Okay. Well, next on the list is Phil, K9Q. Go ahead, Phil.
Hey, not much to report. I'm still recovering what time I have spent on KNIQ radio in the last week has been on a couple other features like receiver voting. So I haven't really done anything relevant to this group. So I'll just listen.
Okay. And then next on the list, we have Tom in N5EG. Go ahead, Tom.
Okay, good evening, Dave, and everyone on the group. Most of the week's been spent looking at alternative design approaches for the multi-channel receiver, but so far I haven't really come up with anything that looks better, more implementable, or cheaper than what we've looked at so far. So that's about it. Back to the group.
Okay, so I believe that I've called on everybody. So, and Nathaniel wanted to talk about abstracts, and then there was one other issue that somebody wanted to talk about. I forgot. So we'll start with abstracts and then be free form after that.
All right, sounds great. So for the AGU meeting coming up on Wednesday, abstracts are due. I am submitting 2 abstracts as the lead author pertaining to the eclipse and the Festival of Eclipse Ionospheric Science. And I'm making this a rather large co-author list sort of abstract highlighting all of the work that we have done on the eclipses as a HamSCI community. So there are 2 abstracts. One abstract is going to be focused more on the results, and it's going to be a very high level discussion of the results, and that's going to be presented in a session that is convened by both the NSF and the NASA program officers. So the same people who are providing all of our funding and have approved all of our grants so far, they're also the ones that are convening the session. So I will share that abstract first. Let's see here. And so I'm calling this one, make it view one page. Results from the 2023-2024 HamSCI Festivals of Eclipse Ionospheric Science and what comes next. We'll go over the co-author list in a minute. This is going into a session called Solar Eclipse Science, What We Have Learned from the Great American Eclipses and What Comes Next. And the abstract reads as follows. Members of the Ham Radio Science Citizen Investigation conducted a wide variety of radio science experiments to study the atmospheric effects of the 14 October 2023 annular and 8 April 2024 total solar eclipses that traversed North America. These experiments all run as part of the HamSCI Festivals of Eclipse, Festivals of Eclipse Ionospheric Science, FOEIS generated a wealth of observations with unusual and unprecedented temporal, spatial, and spectral coverage. Experiments were designed, planned, and executed and analyzed by a collaboration of thousands of volunteer, amateur ham radio operators and others working with teams of professional academic researchers and students. FOEIS experiments included the crowdsourced solar eclipse QSO parties, SEQPs, that used radio signals generated by amateurs and observed by amateur-built global automated receiving networks, e.g. WhisperNet, WhisperDemon, Reverse Beacon Network, and PSK Reporter. Other studies encompassed the HamSCI Personal Space Weather Station Great Amateur Radio Propagation Experiment, PSWS GRAPE, HF Doppler observations using signals of opportunity from the WWV, WWVH, and CHU time standards transmitters, and a long path time of arrival experiment using the CHU time signal, a medium wave frequency recording event, a very low frequency VLF reception exercise, a HF time difference of arrival TDOA experiment, and development efforts for a low-cost, low-powered ionosonde. Experiments successfully captured eclipse effects observed as changes to radio propagation and are now being modeled using ray tracing and SAMI-3 and the SAMI-3 physics-based ionospheric model. In this presentation, we'll provide selected results from the HamSCI FOEIS experiments and discuss how HamSCI plans to use its global infrastructure in the future to study solar cycle 25, the ionospheric impacts of space weather events, and short-term ionospheric variability. Any comments or suggestions?
Sounds great to me.
Yeah.
Well, wonderful. Do you think I can do all of that in a 12-minute talk?
Well,
It'd take you to just read the abstract.
Well, you covered that in less than 12 minutes.
Yeah, well, I guess that's what I was saying, selected results. So this is who I have as a co-author list. So I put down everyone that I was aware of that had some sort of significant effort in the time leading up to or including the eclipse experiments. If you feel you should be on that list and you do not see yourself there, or if you know someone who you think should be added, please let me know and I will be happy to add them.
looks fairly complete.
Yeah, I've noticed that scientific papers tend to have these enormously long author lists. Now I know why.
Yep. Because everyone contributes something, and yeah. So, okay, great. So, and we did spend a lot of time wordsmithing this abstract at one of the Thursday Grape Telecon. So I think it's pretty well developed. So I'm planning on submitting that tomorrow. If you have any comments, please let me know. Now, the other abstract, I'm just keeping the same author list, and this one is being submitted to a union session. So this was an invited abstract, and it's going to a session entitled Solar Eclipses of 2023 and 2024, Results from Participatory Science Efforts, the Nationwide Eclipse Ballooning Project, and Related Engagement Activities. So in this one, I'm focusing perhaps a little less on the exact experiments or the results, and I'm going to try to do a little bit more of a description of how we organized everything and operated. So talking about how we built up this HamSCI community, how we organized ourselves to do these experiments. So more of that kind of community building, logistical sort of thing. So I'm calling this one HamSCI Festivals of Eclipse Ionospheric Science, creating an international community of volunteers to study the ionospheric impacts of the 2023-2024 North American solar eclipses and beyond. And so this one says, this is a shorter abstract slightly. It says, to study the atmospheric impacts of the 14 October 2023 annular and 8 April 2024 total solar eclipses that traverse North America, members of the Ham Radio Sciences Investigation, HamSCI, conducted an array of radio science experiments known as the HamSCI Festivals of Eclipse Ionospheric Science. These FOEIS experiments, which were designed and executed by a collaboration of thousands of volunteers, students, and professional researchers, generated a wealth of observations with unusual and unprecedented temporal, spatial, and spectral coverage. Signal transmissions used by these experiments are generated by both amateurs and national laboratories, e.g. WWV, WWVH, and CHU, highly coherent time standard signals. In this presentation, we discuss the process of building the type of community and environment that was required for success in HamSCI and FOEIS activities. The process included outreach, identifying and inspiring interested collaborators, and providing them with sufficient structure to ensure good science, while also allowing them the freedom to be creative, take leadership roles, and become vested in the project. Special efforts are made to connect participants across disciplines, skill sets, and backgrounds. We briefly describe the hardware and software designed and constructed by collaborators for the FOEIS and conclude by showing selected results from the HamSCI FOEIS experiments.
It looks like a good perspective for academic scientists to learn about.
Thank you.
Yeah, I like it.
Great. And we also did spend time on Thursday talking about this one as well. So this is not the first time these have been seen by people. So great. Well, thank you. So I will work on getting those submitted, and then the conference will actually be in Washington, D.C. this year, December 9th through 14th. So if you're in the Washington, D.C. area at that time, you might consider stopping by. Let's see. And and as we get closer to that time, I'll work on putting together the slide deck. For the results one, I'll probably ask for like one slide from each of the leaders of the different experiments. So like I'll ask Jonathan Rizzo for a slide representing VLF. I'll ask probably Call Deep for a slide representing Solar Eclipse QSO Party. Rachel for a slide about the personal space weather station. I might ask Gwyn for a slide as like that. And and then we'll put the presentation together. We'll figure out how much time we actually have, and we'll go from there. So, or maybe we'll get a poster and then we'll be doing a poster. I don't know. Anyway, I think that's it for now. I think what I'd like to do, Dave, I know Gommel, if he's still around, he really wants to talk with me about his abstract and what he's doing. So I may open up a breakout room, and if I disappear, I'll be going with Gommel in that breakout room to talk with him separately, and you can just continue the rest of the meeting as you done. And I'm going on vacation next week, so I probably won't be here next week.
I wanted to let everybody else know Gamo is in Egypt right now, and this is really early in the morning for him.
Yes.
Thank you for being here.
Thank you. I know he had to step out for a minute too, so I will try to I'll message him in the chat, and yeah, so Dave, you can just continue with the rest of the meeting, and if I drop out, you know where I went to.
Okay.
Well,
thanks. At this point, we're open for general discussion.
I did have another topic to bring up that I forgot to. I'm interested in TEC measurements. If any one of us had, I know we were planning on doing that in the personal space weather station. And there's a project called SynthPy that has a version, their latest version, but they don't seem to have any real information online. Do we have any connections with that, Nathaniel?
Michael.
Michael Howen is running one of their devices.
Okay.
And
but he's not here tonight.
I am also running one at Scranton. So I do have some connection with them. The PI is Fabiano Rodriguez at University of Texas, Dallas.
Okay. I think I just about figured that out. I know they had presented 2 years ago at the workshop. They had a poster. I'll get in touch with them because this is in connection with the project I'm working on, which is, the movie project. We'd like to look into doing TEC measurements, and I know, we as HamSCI are interested in that as well. So,
Would dearly
Thanks.
love to see his source code.
Right. Well, it's interesting. They have their first version online, but the 3.0, which uses the dual carrier receiver,
Yeah.
I haven't been able to find, but I'll get in touch with them and see what we can start working out. So, I guess Nathaniel just disappeared.
Yeah, he's
Okay, so they're hosting units, but don't necessarily have the keys to the kingdom or whatever.
no, they're just installing units that were sent to them.
Right. Yeah, but of course they're using a M9P U blocks, and we designed in the what is it, N9T or something.
Yes. I do know that Michael's installation in North Dakota is co-located with one of your instruments as well.
Right.
The M9, yeah, they're using an M9P currently, I think. Some of us have M9Ps for various purposes. There are also M10Ts and M9Ts, and
yeah, the 9T is what we have designed into Tangerine. So we have them to work with.
Yep.
Mm-hmm. All right. Well, more shall be revealed on that one, but another unit that we could put into our arsenal that's very useful. Okay. And then back to net.
Well, at this point, we're in a kind of open session, so anyone that wants to bring up a topic and start a discussion, please do so.
Well, we were talking the external clock input, which I'm investigating. It's got an odd structure the way I'm seeing it. I haven't powered it up to probe it, but it basically has, at the external clock input, it's got back-to-back diodes, then a capacitor that goes to the synthesizer chip crystal input. The oscillator is fed to that input as well with a 39 ohm resistor, and they must be relying on the back-to-back diodes and capacitor to clip it, because the clock oscillator wants basically a 0 to 1 volt swing. I mean, the input of the synthesizer wants a 1 volt swing, 0 to 1 volt.
Yeah, we've Paul created, and Clint and Paul extensively investigated that, especially after I lost a couple of triple eights, the external clock damage, and I know Clint, as a result, Paul has constructed and is now available from TAPR a little interface board that isolates the grounds and reduces the input signal levels.
Yeah, I
and
have one
ACP
of those.
Yeah, and that was a result of tests of at least a couple of dozen different RX 888s, and with Paul's circuit in place, which I think ends up delivering, if you have a Bogner feeding it, I think that the signal levels are on the order of 250 millivolts, right? Swing, is that right?
I'll have to check the specs. I've got them in the documentation.
Yeah.
Well, I've
cuts
got
it
all
down.
the above to work with. I'm just
for-
beginning to get it all set up. I'm
You know,
gonna put this,
for what it's worth, I'm still puzzled by the input, but I have been able to drive the 5351 very successfully with a 3.3 volt, basically square wave, with a buffer chip right next to it. No no transmission line length. Anyway, 0 to 3.3 volt logic level swing, and it works beautifully. And I'm not the only one. I've seen that
Well,
type of
the
level for a
the
lot of.
spec for the chip has
No,
an
I'm
absolute
aware of this.
maximum of 1.1 volts.
Understood, understood. And it also tells you, you know, that you have to basically that you have to use a crystal in that oscillator circuit. It
No,
doesn't.
it does not say that,
The
but it
the
does say
53.
how it does describe how to drive it with an external signal, but it needs to be padded down to 1 volt swing.
Okay, I'd like to see that spec. The 5351A uh, does not
Yeah,
cover the external signal
actually
input.
it does. The data
Okay.
sheet that I'm working from is the Signal Labs
I,
data sheet.
okay, maybe it's a newer one than I've got. I would love to
Let
see
me
that.
see what page it is on while we're talking.
Yeah, and the date of that, because I've got the this is data sheet or the app note that they have.
This is the data sheet that I'm looking at.
Okay.
And it's Ref 1.0.
Clint is trying to make a
Well,
comment.
I mean, the 1 volt spec that I saw was not a maximum, and it was a recommended. I mean, it just use about a volt if you're going to drive it external.
Yeah, but if you look at the absolute specs, it does say 1.1 max.
Okay.
I'm trying to find the pages.
I think Paul's circuit, which is doesn't drive it that hard.
No, it doesn't.
I have maybe 10 of them with those circuits in it, and I haven't lost
Yeah.
one. And I
Well, the
have
thing is,
good
as long as
stability
you
as well.
current limit it, the diodes are going to clip it to the correct level.
Yeah, I'm not sure the failures that I saw suggested it, that in fact there was other failure modes that the diodes. I think Clint, you were the one who suggested there's another failure mode.
Well, the problem is the back-to-back diodes, one side of them is connected to the local point of load LDO, low dropout low dropout regulator. And if you get a signal that it exceeds that on the input, say from a ground loop, you actually over voltage the LDVS driver and the 5351 voltage power supply and blow them up. That's the failure of ROBs, because what it doesn't clamp to anything with any substance. It just shunts it right to the V plus supply, and that rises above. And Rob managed to, I'm sure through ground loops, pop both the LVDS driver and the 5351. And I just Scilab's 5351 in there.
Page 9 of the Rev 1.0 data sheet has absolute maximum ratings, and it says input voltage on XA/B is minus 0.5 to plus 1.3.
Clock X. Yeah, I've got a Rev 1.1 spec. Anyway,
in this one, it's table 10, absolute maximum ratings. If you do a search, you'll should go to it.
So does this have anything to do with, I had read, and I don't remember where I saw this, was the SMA connectors are a problem because when you connect them, the center pin connects before the ground or the shield connects. So if you plug them into a working system, you can essentially blow stuff that way.
Yeah, exactly. That's what we believe happened to Rob.
Yeah.
And Paul's board sidesteps that problem reasonably well. I mean, if the first thing I recommended was, for people doing this stuff is for God's sake, just screw a 10 dB resistive pad on there. And that at least before you put on anything else, and that does several things. And I think that's kind of what you have built into yours, Paul.
Yeah, no, I've got, nothing's going to protect it from a horrible fault voltage or current at the input, but I've got a resistive pad, I've got capacitive coupling, and the resistive pad is designed to provide impedance matching in both directions because we still got a short, few inches of coax, micro coax cable internally, just to get to the circuit board from the back panel to the circuit board. And that is not terminated properly. So my board does do a termination so that the reflected signal gets terminated and you're not going to get ringing out of it. So anyway, it tries to preserve the waveform with reasonable terminations and also, AC coupling to avoid DC ground loop issues, and then just attenuation as well to avoid overdriving. Because I was seeing the effects of the diodes in that on the 888. But again, David, if you can, your schematic of the input, I would sure love to see it.
Right. Yeah, and it
Oh,
has,
Rev
as I say, it's got
1.3, okay.
back-to-back diodes right
Yeah.
on the external clock input.
But they're now Clint was seeing that one. Clint, you saw
Well,
diode up to VDD and then diode to ground, and Dave,
well,
you're saying they're back to back?
it's a BAT.
No, they're back-to-back to ground.
It's a bit. Well, the ones I saw used the BAT99. I think there must be
Correct.
some differences
It's a
because
BAT99 with both of the split diodes grounded, and the center is connected to external clock.
well,
So it's, if you test it right at the pin or whatever, you'll find that there's a diode to ground both directions.
well, so there's a difference. The one that I repaired for Rob, there was a DC continuity between the center pin and the clock input of the 5351. There absolutely was. And also one side of the BAT99 was tied to the 3.3 volt supply.
And there may be different versions, because this one's got a blocking capacitor.
Well, and if you look at them, some of them have the trimmer resistors for the VCT-CXO and some don't. I mean, there seem to be subtle differences between these units.
Yeah. I guess my poor man's way of protecting the circuit was to put a SMA to B and C adapter on the connector, because B and C's will always connect the shield first.
Yeah, well, of course, you can always connect it powered down.
I mean, that protects you from some faults, and that's not a bad idea. Obviously, there are an infinite number of ways to blow this up. I think,
and we will find every one of them.
Oh, we'll find, and infinity minus one or something.
Yeah.
So anyway,
if there are differences, that's a little bit problematic. It's hard to determine that, given that this circuitry is under the shield.
True,
you have to
but
pull
I think
the shield off.
With what Clint's been doing, or the board that I designed and TAPR's selling, the diodes are kind of irrelevant in normal operation, because we're not causing the diodes to conduct. We're getting close. But so regardless of the configuration, it shouldn't make a whole lot of difference in normal operation. Again, in horrible fault situations, that could be a different story. But I'm not aware of anybody that's blown up 888 having put one of the adapters inside it. Rob, have you heard of anything? And you've run a bunch of them now.
Yeah, I have four of them out at KFS and two at KPH, and a couple more. I have one that's failed, that's at in Albuquerque, and I don't know why it failed.
Well, one reason I'm particularly interested in knowing it intimately is because of the way this is mine that I've set up. It has the external clock input, and it's direct in, and then I have a switch that switches from internal to external. So I don't have to go in and change things if I want to run it standalone.
Is that switch just on the enable signal for the
it
clock
basically
buffers?
goes into those two pins.
So you're basically a stub connected to that. if maybe a terminated stub, depending on how your external
Yeah, well,
connector
that's
goes.
part of the reason to look at this, in that it's now got a stub on it.
Yeah.
The way they designed this, it doesn't switch it in and
Yeah.
out. It's still part of the circuit.
One thing to keep in mind is that the 5351 spec sheets have always been very problematic, shall we say, at least in terms of the you the register definitions and descriptions and the use descriptions. There's a bunch of stuff in there that's either wrong or incomplete. So it wouldn't surprise me if they're absolute maximums or whatever. They could almost be placeholders as far as we know. I wouldn't. It's good to observe the maximums, but I wouldn't want to bet that those actually have much relationship to what's really going on. Yeah, there's some relationship.
Okay,
Maybe it's accurate. Maybe it's accurate. I don't know.
Yeah, no, I just downloaded their latest, which is Rev 1.3. The table number is different. They've added some other tables. So this is table 13, but it still has the table for absolute max, and it has that same spec.
You know, I've never looked for the M-Star variant data sheet, because these are M-Star chip. I mean, the ones that come with them are M-Star chips. So yeah, that'd be. I wonder if that's obtainium or in something other than Chinese. But yeah.
Right, but this is not. I doubt that this is different, because this is the input to the crystal oscillator circuit. And it all makes sense. It's just you need to limit it to this.
I mean, it may have different or more information.
Yeah. Okay.
I mean, the inaccuracies may not be the same all the way across.
And then, actually, in terms of where so the A version, it only has the clock oscillator, the crystal oscillator input. The C version is the one that has clock in, which would be convenient. But if you know how to attenuate, it's not necessary.
Yeah, I just want to. But there is evidence, mine and other designs that have been built in massive quantities. QRP Labs, for example, where they are driving that crystal oscillator input with a 3.3 volt signal as am I, and it's been working long term and reliably. So nothing wrong with I think it's probably all things equal, driving it with a lower voltage was probably advisable, but I'm not aware of any issues showing up when you drive it hotter than that.
Although one thing that's worth noting is Michael, what's the one that Juan, or you know who I'm talking about? He's on the Whisper Demon groups.
Oh, what Michael Howan? Yeah.
Howan, yes. He was having issues with an external clock, and we discovered it was, if you run any length of coax, the diodes would conduct and double the frequency. So he had exactly double the clock frequency going into his 5351. Caused by doubling by triggering on both edges from
that had to be an unterminated or proper.
Well, it was a transformer coupled.
Yeah, that's not going to terminate though.
Well, what he tried to do is we're trying to get rid of ground loops. So he fed this clock into a T11 transformer, then from the T11 with just a short jumper into the 888, and that didn't work at all.
Yeah.
I mean that doubled the frequency, and the reason I figured for that was that you have a bipolar signal when you transformer couple it, and that is not. And
the
also
external clock input wants a bipolar signal.
But you've got an unterminated cable from your clock source all the way into the 5351 input, and that is going to
Yeah,
But you,
the way to avoid that is to use series termination at the driving end.
Yeah.
um,
Well, or just a matched driver should absorb the reflected
Yeah,
signal and then
that'll do it too.
not get
You
multiple.
also if you drive it hard, you're also going to get into the reverse recovery time of the diodes.
Yeah.
I think it. I think the diode was clamping the negative swing out of the transformer, and then all bets are off. All
No,
down the line.
on one of my Whisper Sound prototypes, um, I was distributing 10 megahertz clock, 3.3 volts to 4 different 5351s, and I did a shitty job of it. The signal was not particularly clean, and some of them were working fine, and the 5351s, and others they were running at weird clock frequencies, and it was because of a bad wave shape on the reference signal. So you need, so I've seen it when I screwed up. I've seen the effect of that. I then relayed it out with individual buffering and termination for each of the clock lines, and feeding them a nice solid clean signal, and works great. But it is sensitive to distortion products. You probably most likely ringing, or even
Yeah, but if you
doesn't have to be
can
hard
get it
ringing.
clean, if you do a parallel termination and feed them as a daisy chain, as they're high impedance inputs, as has been noted, they're not terminated internally. You terminate at the end at the last one, and you can get a clean signal that way.
Except for the stubs, or depending on your daisy chain.
I mean,
that worked. That worked
Anything
for me.
less than 6 inches is going to be not a problem.
Yeah. I
depends
daisy
on the wave
chained
shape.
4. I daisy chained the 4 out of KFS.
Your transition time isn't going to, a 6-inch stub is going to be less than a nanosecond.
Depends on the rise time of the signal you're feeding.
That's right. But these are like, they're going to have about a nanosecond rise time.
Well, I
less,
feed
or
the
more.
ones we have at Northern Utah where you feed with a sine wave, and also I don't think
That
they
also
designed
works
external clock of the 888 with external clocking in mind. I don't think they did.
Well, they weren't really thinking about how that would be
no.
driven.
Oh no.
And I'm not sure what, I need to look into what exactly is going with the TCXO, because do they actually trim it, or does it have an enable input?
Well, the one that I did has an enable input. I mean, that's all the external clock jumper does.
That's what I thought.
It just tri-states the clock, because they're all in parallel with each other.
So it must have an inverter in the way, because it's not directly connected to that input.
Well, there we go. The one that I fixed for Rob, there was DC between the center pin all the way to the 5351. You could just just dome it out. So maybe they've been been reading forums or something. I don't know, but
I got
these are all older ones. So.
Yeah, I got a new batch of ARC 888s, and they had a black PCB, whereas earlier ones were purple.
Right.
So I think there may be 2 batches or 2 manufacturers or 2 versions. So
there's a clone of the clone.
I think they're like Baofeng radios. That's what this says on the label, but that's not who makes them.
Yeah.
Oh yeah.
Rob, have you tried turning one of those on yet? Running it, doing the
they're out running it. 2 of them. I put your adapters on it and took them out to KFS, and they're up and running. I haven't really paid much attention to them, but they should.
That's a good thing that you don't need to pay attention. Yeah.
I need to go out and change out all of them. I hand built some attenuators and isolators that I'd like to get rid of and put yours adapters in its place.
So just so you know, in one of my previous incarnations, which happened to be actually pro audio, digital audio, I've got a lot of experience in that. I was known as the Terminator because I knew how to handle these high-speed signals. And we actually had 50 megahertz running around in our instrument, various places, which of course had to be clean.
Yeah.
You haven't been miserable until you've tried to get analog video to play nice.
Indeed.
Yeah,
I know about that too.
The fastest stuff I was involved with was 10 gigahertz fiber optic modulators for products. And yeah, you got to be careful. I think what we have now with the adapter you can get from TAPR, it seems to do the job. And
Yeah.
it
Well,
does
I
hold.
have one. I did get one of those. So I am in the process of hooking that up. This is where I'm interested in rationalizing exactly how this is all working.
Yeah.
Now, if there are two different versions of the card, we're going to need to determine that.
Yeah, and I hope it's a difference, without a distinction or whatever you want to, a distinction without a difference. But it'd be nice. I just love to see a schematic of it.
Well, I'll certainly share when I feel I've gotten this so that I understand it.
Okay.
I'll certainly share.
I appreciate that.
I reverse engineered the one that I got from Rob, made a bunch of notes, but it's like reading a series of data sheets. I mean, the only thing I didn't really examine was the B output of the 5351 feeding the Raphael converter. I didn't look at all at that. Because yeah, well, whatever. But it looked like just application data sheet one after another, just from what I poked at. The one thing I did not like was the blocking choke for the DC bias. I don't think is an appropriate device for a wide frequency range. It's appropriate for LF, but I think it probably has an SRF that hasn't been investigated. But
you're talking about the bias T inductor?
Yeah, it's the same inductor for used for both the HF and the VHF input, obviously. Now there may be a 0204, there may be an O2 part SMD inductor that I missed, but still, I've run across that before.
I'll take a look at that too. I handle those all the time too.
What Clint, tell me about the DC feed coming out of the antenna port. I've never looked at that on the 888. What does it provide?
Just 3.3 volts.
Oh, okay.
Yeah, I mean, there's a FET on there. I think it's I think it's just a P channel FET or a PNP. I forget which. It just gets yanked down by the FX3, I guess, when you command it on. It's nothing special, and I don't think it's current limited, except maybe there's a PTC on there.
Yeah,
but
3.3 doesn't help me out much. But okay, I just want.
Yeah, I wish they'd feed 5 instead of 3.3. It's a lot more useful.
Well, GPS receivers work well there, but yeah, getting something with good dynamic, something that will drive to -15 with low IP3 off 3.3 volts is at maybe 50 milliamps. I don't know how you do that.
Right. Yeah, my GPS antenna's like 5. They don't like 3.3. Not that I'd be hooking them to this, but could.
So anything?
We if we beat the external clock subject to death, we were, I don't know if we seem to have lost. No, the time of flight was a major discussion last week.
Yeah,
and,
I was very heartened, shall we say, by how that took off. I would I'd love to follow up on the kind of the universal transmitter idea versus other techniques.
I think your point, I think, was, if I recall, your point was that you can think you can generate a couple thousand frequency transitions per second out of a 5351. And it can't change.
Yeah.
And I guess your question was, could useful time of flight measurements be made from a signal generated just with such frequency transitions?
Yeah,
As opposed to a full IQ modulation approach to generating a transmit signal.
Yeah, again, just trying to establish, a baseline, is, what is it we're trying to measure and how simply can we do it? And then, what could we do if we had a more complicated, more universal, higher precision method? And, one stake in the ground is the 5351 capability, and you can update that thing a couple thousand times a second. I squared C, and depending on the computer what's generating the I squared C, you can pretty accurately control the time of these transitions. So does that provide anything that's interesting or useful? And if so, what would, can we come up with a modulation and a protocol? It's either going to be BPSK, because I can do that at that rate too, which definitely is generating a broader signal, or 2FSK or 4FSK. It doesn't really, all of those are possible, but these can be done within the 2.8 kilohertz occupied bandwidth specs that we can now work with. Or you can make it narrower and slower if you want. But again, is that useful? And if so, how do we do it? And then the other question that I haven't even started to ask is, I've been looking at how the whisper decoding is done, and apparently we've got like 2 FFTs per symbol rate, which is not over. That's basically Nyquist rate sampling, which kind of surprised me. And from that, assuming that you do your time of reception measurements, time of arrival measurements based on the FFT calculation, you get 2 samples per symbol, and the symbols are, 600 something milliseconds each. And then you can interpolate across, what is it, like 162 symbols in a frame, some number like that. And I think that's where we get like the 10 milliseconds. What's the time of flight that we're trying to measure here, and what's the variation? Is 10 milliseconds just so grossly in excess of the fine detail we're trying to resolve, or is that a useful resolution just right there?
Well, how about Paul? I mean, the other way to skin this horse, cat, whatever mixed metaphors would be, on multiple sites, bang the received signals together and do correlation there. You would have an absolute time of flight, but you'd have a different delta between the two sides, which enough points of data should give you something useful. And the advantage, well, I mean, you can, I mean, it's like TDOA, of course.
Yeah, I think that, from what I think Gwen and has been looking for is the ability to differentiate between the different paths, the signals, multipath signals. So a technique that allowed you to isolate the individual paths from transmitter to receiver. It's not. This isn't the purpose of this. Is not geolocation or transmitter location. It's to determine the motion of the ionosphere and the effects of ionospheric changes on the actual path of the signals.
And it doesn't have to be multipath either for that. I mean, that's one interesting parameter, but even a single path, we can get Doppler shift on a single path right now, but we don't know the path length, and the time of flight gives us, another dimension on that.
Well, Paul, just for your reference, 11 milliseconds is 2,000 miles.
Yeah.
Yeah.
That is not helpful.
Yeah. 300 million meters per second is that number's been into me many, many times.
So we're looking for microseconds at least.
Well, I remember from Steve Serwin's paper, his examples were like in the 1 millisecond range. So,
For delays.
For delays,
That was differential, wasn't it?
And that's differential.
That's a differential delay, yes.
Yeah.
But your resolution, you want your resolution to be much better than that.
And then maybe within the 2.8 kilohertz occupied bandwidth of the ham bands, that's just not practically doable. I don't know. To get a microsecond,
Well,
I'd
this
say
is what I was saying last year. I mean, we can always do time ticks, and I don't actually know what the WWV bandwidth is on their time ticks. They are, 5 cycles of 1,000 hertz.
You can easily see just by looking at the spectrum.
Yeah, I know. I was kind of eyeballing it, but I think it's within the 2.8 kilohertz. But the thing is, what I'm curious to find out is what Juha Viernen uses for his low power ionosonde, because he uses coded transmit waveform, which you can get much better spatial resolution averaging over time.
Well, there's also this Part 5 license from Professor Heisel at Cornell, which he in his license application says they're going to use it to make time of flight measurements.
But we haven't been able to find out anything.
We haven't heard. I did.
No.
I know you haven't, and he hasn't responded to your email.
No.
And I'm not sure that. I think Nathaniel's been distracted to try to.
Well, we know him too.
Maybe
my boss actually knows him very well. He's from Cornell.
So
what is it you're trying to find out?
Oh, what's his modulation? What's the format? What are the results?
Has he not done any papers on it?
I don't think so. He just got the license, so it looks like he's starting.
It was a couple of years ago, I think, maybe a year ago. But no, I mean, I'm not clued into the scientific network really. So, my meager skills at Google searching turned up nothing of any significance beyond just the FCC, authorization.
Does
no
the
other
FCC
details.
license mention a project by name?
It's possible. I'd have to dig into that and find it again.
I should take a look at this. Yeah.
Well, I sent what I knew,
we,
David. I could forward you the email. I forwarded Paul's email to Nathaniel, and
we actually have one of our receiver that David Eisel is hosting for us.
Well, let me see if I find it. I'll forward the Paul's email to you.
Cornell's website's not working.
Yeah,
there it is.
So Steve Serwin's paper tells you exactly what waveforms that they use for their test here. There was 5.
Right, but he's doing a chirp waveform that's intended to get time
differential. Yes. Mm-hmm.
Not
so that you can see
time of flight.
The velocity of the movement of the F2 layer is what they're trying to
right. Yeah, we're looking for the Doppler shift.
Yeah.
Essentially.
Yeah.
But yeah, and chirped waveforms are what they use for a lot of the ionosondes as it is. The problem is that we can't chirp over wide bandwidths the way the regular sounders do. But we can receive the existing ones, which I know Nathaniel has worked on that. Again, UHA's developed a system to be able to use that.
You'd have a wide bandwidth receiver then to be able to receive the entire chirp. Yeah.
Yeah, well, the RX-888 is ideal for that.
Right. Yeah.
I think this was developed on a USRP, but this will work fine because I don't think it's using any of the processing in the USRP. It's just the A to D.
Yeah, because the chirps that Steve's paper used went from 0 to 5 kilohertz. So
right. Well, those he was broadcasting through a ham transmitter.
Yes.
But the chirp sounders, ionospheric sounders, are going, from like 2 to 18 megahertz.
Right.
2 to 12 megahertz.
Yeah.
Yeah,
I see them occasionally go through my waterfalls.
The other
Are those
thing,
the ones
the other
that sweep
signals we
slowly
might
that
be
you?
able.
Are those the one you see sweep slowly across an entire band?
Yeah,
I
presumably.
was wondering about those.
Yeah, you see those all the time.
I have one of those transmitters in my garage. Utah site used to be one of those sites.
Ah.
Yeah.
But it sweeps over like multiple megahertz?
3 to 30 is the one is the range of the one that I have sitting in my garage. Although they mute over certain frequency ranges, if you watch them carefully, like the emergency frequencies and some of the airline frequencies, you'll see them mute.
Yeah, just as Super Darn's not allowed to transmit on our ham bands.
Do you want them to?
No, we don't want them to. They're not allowed to.
Right,
they have to. They have to blank those out.
In terms of the time accuracy you can get with a certain bandwidth, it's actually better than just one over the bandwidth.
Right.
Imagine you're sending a PN sequence at that chip rate, and what you get is a correlation function is a triangle. It's obviously maximum if you're right on the chip, but and it's 0 if you're one whole chip off. But in between, you do get a partial response, so you can track within a fraction of a chip, depending on your signal noise ratio.
Well, ELORAN is reporting sub 10 meter accuracy with what's their operating bandwidth? It's got to be 20.
Oh yeah,
20 kilohertz.
Yeah.
Another good example. Yes, another good example is LORAN. Yes.
Yeah. That's a very good example.
Now, just to put it out here, I have recordings from both October and April, and I transmitted from both ends a broadband BPSK signal from the eclipse path. And for hours and hours, just every second the phase flipped 180 degrees. The bandwidth of it was about 15 kilohertz, although the 26 dB bandwidth is much less than that, and that's all the FCC really cares about.
Where did you send this, Clint?
So my version of the Whisper Sonde, everything starts out at 45 megahertz, and one of those 45 megahertz carriers, on a 1 PPS, the phase flips 180 degrees. And the only thing constraining the bandwidth is the 45 megahertz bandpass filter, which is about 20 kilohertz, maybe wide.
Oh, but you're only flipping every second?
Correct. And I also have a matching in the same passband at the receive site at Northern Utah. I have exactly the same hardware on a slightly different frequency. So contained in those recordings for a long period of time, there are 2 phase flips that go on for a long damn time that, in theory, I guess could be correlated.
Okay, and those phase flips are essentially instant?
Correct. I mean, they're like 13 microsecond. No, they're essentially instant. The limitation is the bandwidth of the 45 megahertz filter, and of course, SNR. But in the recordings at the Utah SDR, I have both what I'm picking up from Texas or southern Utah in the case of October, and plus the locally generated identical signal. So I have exemplars of both signals in the bandwidth. In theory, I suppose I could probably examine the waveforms over time, correlate them, and figure out, slide them back and forth and figure out the best match, and figure out with probably within a few tens of microseconds in theory, I would guess.
This was otherwise a standard whisper signal?
Well, no. I was transmitting 3 signals per band. I was transmitting 24 signals for both October and April. I was sending the whisper signal, a dead carrier with no modulation at all, and this flipped carrier.
Okay, and the flips were not synchronized with the symbols and the whisper modulation?
No, they were totally independent. They were flipped from the 1 PPS output of the GPS receiver.
Okay, so they're going to flip at some random time within each symbol.
Correct.
Which is going to interfere with the ability of a normal receiver to receive that.
Well, that has
they're not on the
nothing to
same.
do with whisper, right? I mean, it's independent.
No, they were on separate frequencies. There's 3 separate frequencies. All these 3 carriers are 500 hertz apart each. So I mean, they don't know each other existed. The other 2 were.
Oh, you didn't expect anybody to be able to decode this with a normal.
No. I did that because it was easy to do, and there's a non-zero chance that might be useful. It is much more useful to send this data and not use it than it is to never send the data and not even have the option.
Now, you say this was at 45 megahertz, though?
Well, I generated everything once at 45 meg. Then I converted it down for each individual amateur band.
Oh, I see what you're saying.
So I in fact, I used one of Paul's boards at 45 meg to generate 2 CW carriers and the Whisper or FST4W. Then I converted it down. So my equivalent of the Whisper sound has one box that 45 in out and all the bands out on the other side.
Funny thing is, this thing would sound just like a whisper signal, but it probably wouldn't be decodable.
Well, no. Well, so there's a whisper signal, there's an unmodulated carrier, and then there's yet another carrier that went click, click every second.
Wait a minute, were you modulating the whisper signal or the carrier?
No. I was sending 3 signals.
But as long as you're sending the whisper signal out at the appropriate time, then people would be able to decode it.
So I was sending a normal whisper signal. 500 hertz above that was a dead carrier with a CWID on it, reducing the amplitude every 10 minutes. And then 500 hertz above that was the signal with the BPSK, one flip per second. So
what else was on the upper carrier besides the BPSK? Was there anything else?
Nothing. Other than every 10 minutes, I dropped the amplitude by about 6 dB to make it legally. So you can.
Oh, okay. So the one that was being BPSK modulated at 1 hertz had no other information on it other than the
correct. And the CW carrier had no other information. And I did the CW carrier because I still haven't pulled my data, but from the hard drives at Northern Utah. But that gives me continuous real-time Doppler shift information, and I need to get that and send it off to Gwen.
Yeah. So these were GPS locked frequencies.
They were rubidium, which is better.
Okay, close enough.
Because one thing we noticed during the eclipse, both in October and in April, was during the peak of the eclipse, we'd see the Bodner just do this. Over a few seconds.
Bodner is not stable.
So it was almost invisible during normal sun time, but during the depth of the eclipse, you could see the thing starting to hunt.
Right.
And it was tens of degrees. I mean, over a period of about 5-6 seconds, it'd hunt back and forth. So that's why one of the reasons, and plus my rubidium's better than the Bodnar for absolute frequency. Anyway, now, but Northern Utah was using a GPS DO with actual inertia in it, so it shouldn't have been a problem.
Right. So, a GPS DO that uses a proper OCXO would be fairly stable.
Yeah. So we have all that data. We have all that. I have all that data. I just keep needing to pull it off and process it and get it to Gwen for the real-time continuous Doppler data. And that's also why I was asking for recordings at the time of the eclipses, because if somebody recorded the IQ passband, then they, with a GPS locked receiver, they would have that information too. And practically speaking, having multiple simultaneous Doppler data from different directions would probably provide valuable insight to somebody, I guess. I mean, I wouldn't expect the Doppler to be the same in all directions.
Nope.
And if it ain't, that tells you something.
If I'd
But
known, I could have recorded that.
I guess if it's GPS locked though, using a Leo Bodnar during the eclipse, then that receiver was not stable either.
Well, I neither transmitted nor received using a Bodnar.
No, but you were saying if anybody else had recorded it,
Right.
right?
Well,
Yeah.
that's a good point. If you're using the Bodnar to record it.
Well, I guess, I mean, if we're down to, if we're back to, I mean, we're talking about, you know, wobbling phase a few degrees at 10 megahertz, you know, a few tens of degrees. So over time, it probably would come out in the wash, but you'd probably noise up the data a bit.
Yeah.
And it depends on where your Bodnar was relative to the eclipse path.
Right.
So
we have an example of n equals 2 of this happening with the Bodnars.
And so the interesting question is, given this, you know, basically a half hertz data rate, you know, carrier flip every second, and whatever the bandwidth is on the modulator there, what is the time resolution we can get with that, and how long does it take us to, you know, there's also kind of a sampling theorem thing, so it changes, you know.
Right. I mean, in the case of, well, I think Phil alluded to it. In the case of like a Loran, you have low resolution pulses, but lots of them. And you can, I mean, you can trade off lots of data, lots of slow data for good resolution over some period of time.
Yeah.
Depends on your signal noise
Yeah, it
ratio.
can also find the zero crossing much more accurately than just the bandwidth would imply.
If you've got a lot of signal noise ratio, sure.
Signal to noise ratio, and you know what the waveform looks like.
And if you know, if you compare it, correlate, self-correlate, you know, and you know exactly what you're looking for.
Exactly.
Yeah. I mean, I'm just trying to think of, I mean, knowing that, is there something lower resolution that you could do?
We could also flip the carrier at a much faster rate if you wanted.
Well, so when I was building my my beacon, my envisioning was 200. This is before we were given 2.8 kilohertz bandwidth. Was having an I channel at 256 chips per second and the Q channel at 1, flipped by and they would be both synchronized to the GPS receiver. And I don't know, and I didn't build that because I like. If I'm going to do something with it, I could probably more likely do something with a BPSK signal and correlate it using more manual means than trying to recover that, because I'm not that much of a DSP guru.
So that's another question is I'm looking at you, Phil, somebody's got to build a receiver, something to demodulate this and extract the information from the signal. So the signal has to be.
Yeah, it depends how wide do you want it to be? I mean, you know, this is.
You know,
well, I mean,
I think that's what we're discussing right now is, you know,
well, I'm telling you what you can do, right? I mean, if you got a bandwidth of 2.8 kilohertz, we can certainly do better than 300 microseconds. We can probably do quite a bit better than that.
So, I mean,
with a signal that Paul could generate just by changing
it depends on the signal noise ratio of your channel, right? And because I can't integrate forever, because at some point there's something we're looking for, right? We're not just doing this for the hell of it. We're trying to measure a channel, right?
Yeah,
right.
and I think,
which means you can't integrate forever because the channel is going to change eventually.
Yeah, and if the thing we're trying to measure changes at a certain rate, it's not going to, you know, it won't be constant. A constant delay, that delay is going to change, and if we want to track that delay, we can only integrate for so long.
That's right.
before we filter out the thing that we're actually looking for, or one of the things we're looking for. And whether or not I can generate it with a SI 5351, that's really a secondary issue. I mean, it's interesting to me because I like to build stuff, but if that is a particular dead end, then that's fine. However, Clint, I mean, I could certainly do a BPSK
Well, I
carrier
did that.
flip at any rate you want, and I could do it, synchronized, down to the sub-microsecond level.
Well, I did the BPSK because I could do it with a diode ring mixer.
Mm-hmm.
Now and a flip flop. Literally, that's all it took for me to generate that. And I did it because it was the dirt simple, easiest possible way.
And you got away with it because your rate was so low that the amount of energy in the sidebands was negligible. Nobody would be bothered by them.
No. I mean, you're right. And the FCC only cares about things above 26 dB, minus 26 dBc anyway. So,
okay.
So, I mean, I went undetected, literally, I guess. No complaints.
Where do you get the minus 26? Because I've been seeing like, the occupied bandwidth stuff, it's like 99%, and that's 20 dB.
Well, that's where it comes from, isn't it?
Yeah, so why the 26? That's all.
Well, I come from the satellite world, and the FCC on a satellite transponder, the FCC didn't give a rat's ass what the spectral regrowth was, as long as it was below 26 dBc.
Oh, okay.
I mean, more or less. Well, I mean, 26. The envelope was 26 dB down, and I've also.
I'm going to say it doesn't really matter, 20, 26, whatever.
Right.
It's just interesting. It's nice to have a spec, that's all.
And 26 dB is probably not a bad choice, because if you have if you have a strong audible carrier, 26 dB down is going to be kind of hard to hear under normal band conditions, in quotes. Air quotes.
By the way, I found that
from the latest Part 97, bandwidth is defined as the width of a frequency band outside of which the mean power of the transmitted signal is attenuated at least 26 dB below the mean power of the transmitted signal within the band.
Oh, okay.
The FCC likes 26 for some reason.
Yeah.
But anyway, but I guess the other question too is we have well, first of all, whatever we do, we cannot use any spectrum language, because how the FCC is.
We won't call it that.
No.
Use what?
Correlation pattern or something. I don't know.
Okay, you only have to look at the fiasco related to the ROS digital mode, ROS digital mode from about 15 years ago. I mean, if you look at that, he made the mistake of calling it spread spectrum, even though it was just a crap ton of forward error correction, really, a lot of extra data. And the FCC said, spread spectrum. Nope, you can't use it. US hams can't use it. So
you can use spread spectrum at 900 megahertz and above.
That's right, but not on HF.
Right.
It was also before these HF rule
If I might interrupt,
yeah,
I just found a description of David Heisel's transmitters. This was actually a system he's got down in Peru. He studies the plasma bubbles around the equator.
Can you send the link? I'm looking at what you put up there. Thank you. I'm going to copy that.
So
is there a link involved?
What I was talking about is using a pseudo-random binary code, and then I can't believe the gain that he gets in here, but clearly he knows what he's doing. But yeah, let me just get the link of the actual paper. This is describing his
compression
Peruvian
ratio
system.
A compression ratio of 10,000. I'm trying to wrap my head around that.
I'm not sure exactly what that means, but then what gets me is that he subsequently increases it by a factor of 1,000,000 in each Doppler band through coherent signal processing. But this is what you can do if you know what your transmitting waveform is, and you analyze it.
Is compression ratio just a renamed chipping gain?
Probably.
I guess
that's what I was trying to think of.
Yeah.
I mean,
I think
that's not too hard to do.
He can get very tight resolution about And what he's doing, he's sending these two frequencies up and getting what he calls a pseudo range off the F layer.
Sure. Just like in GPS.
Right.
By the way, a 26 dB rule is equivalent to having no more than 1/400th of your power outside of the bandwidth.
Okay.
Or 99.75% inside.
Yeah, that's a lot of power, actually.
Right.
That can cause interference to a weak signal.
Not
well, it's total, the total power of 26 dB, not on any
yeah,
one
but
frequency.
if you put it in, if it happens to be in one frequency.
Oh yeah, yeah. I guess yeah, right.
Yeah, and
it doesn't say that.
It's not written that you have to spread it out.
Many of
We're
the
not
other
allowed to
FCC
do
rules
spread
talk
spectrum.
about spectral densities. The rules don't mention spectral density anywhere that I've seen.
Right.
I just remember that in Japan for our key fobs that we had to have no more than 250 nanowatts of power outside our channel.
Mm.
Man, you guys, this is
they were
never fails. This is getting really interesting, and I got to bail out. Somebody take notes and let me know what you guys figure out. Okay.
Well, somebody's recording this thing actually.
Is that okay?
It
good.
is still being recorded.
Yeah,
okay.
the recording is still going. Yeah.
Okay. Well, I gotta go, but by all means, carry on. Yes. Boy, this is good stuff.
So Phil, I can imagine 300
Adios.
people transmitting 2.8 kilohertz noise, wide bursts of noise. Would there be any hope in the hell of having a little enough cross correlation between the chipping codes, which are not going to be chipping codes, that the thing would actually work all on one frequency? I mean,
well, it depends on how close the receivers are to the transmitters.
When the propagation, of course, yes.
Yeah.
Right.
Also depends on integration time.
Right. I mean, I'm thinking of the viewpoint of if we had the system 2.8 kilohertz wide, would we quickly I mean, the people doing this become a damn nuisance in a real hurry, or I mean, or
well,
what?
to ourselves or to
everybody.
Well, I'm assuming that we're going to have a 2.8 kilohertz channel that's going to be ours.
Right. But I guess the idea of having time of flight would be for having time of flight for many people. And
yeah.
there's the rub, to quote somebody.
Yeah, well, you want to be able to, you have one transmitter and multiple receivers.
Right. Well, I mean, ideally you'd want multiplicity of everything, but I guess the question I haven't heard. Rob and I were talking about this on the Wednesday meeting. Is that has anybody actually decided how good is good enough? I mean, would we be happy with 100 microseconds, which would be 18.6 miles roughly? I mean,
that's pretty coarse resolution. You're looking at things that are like 100 to 300 miles up.
Right, and of course the angle. I mean, yeah, but I mean, even if it were 100 microseconds reliably, that would be extremely much better than what we have now. But I mean,
right.
what is useful and what is practical? I think there's a big, huge gulf between the two, right?
Now, there's another thing that we can be working on is we could use real, actual signals transmitting information such as Whisper or FT8 or whatever. And as long as the start of transmission is at a known time, you can consider that a pseudo-random code. And you can decode it and then post-process it and get a time out of that.
I mean,
that's what you're going to do.
Right. What I'm saying is you can use existing signals of opportunity.
I mean,
as long as we're trying to get these things GPS synchronized. If you do that and they start on, on the GPS second.
Well, I mean,
that may give us the information without having to come up with a wholly new modulation scheme.
I mean, well, to get back to what I was saying before, if you have any random signal with modulation on it that is out there, that if you know the precise characteristics of that signal, you can do something with it. I mean, ideally, you could have a monitor right at the transmitter to go from. I mean, if you fully understood it, I mean, like a shortwave broadcaster in Tennessee, with all the music and everything else, could be considered a pseudo-random signal for all practical purposes.
And people do that.
Right, and you could correlate that either at multiple remote receive sites or even have something local that would do that.
How about using a transmitter whose program is already known?
Well, like WWV or CHU.
Like WWV,
Well, yeah,
because I've written a program. I've written a program that generates WWV's program, except for the voices.
But what I'm saying is that you know what the program is because you can decode it.
Right.
And as long as you know when it started, you can post-process it.
You're still talking about a special purpose.
No, I'm saying use FT8 signals, for instance.
Oh.
And since you know that it's going to change at specific times, it's going to start at a very specific time, and you can decode the message so you know what the frequencies within it are. It's just like having a pseudo-random code that you decode using.
Well, except that it's changing very slowly, so the resolution
is
good.
Except that may be okay because we have the cycle zero crossings, plus we have these edges that help us.
I'm not sure I follow that. I mean, we're just saying that
remember,
you're going to get enough.
Remember how much resolution you can get out of a Loran C signal.
Yeah,
100 kilohertz. You're pulling it out of the zero crossings.
That's right, because you can average over long periods of time. It's a very powerful signal.
Yeah, though each of the chirps in it is about 1/10 of a second. No, considerably less than that. The repetition rate is 1/10 of a second.
Well, the GRI, it's whatever, but
right, the group interval. But I'm saying the individual, 8 pulses is quite
there are
quick.
cycles of 100 kilohertz that are shaped in a very specific way.
Exactly.
On like the third
we
zero.
We can do that too. Within our bandwidth. Anyway, we should play with it.
Well, I mean, here's, I've been trying to rack my brain as what would give useful information, like the message from, the thing about the 2 transmitters with frequencies operating at slightly different frequencies. I mean, like they do that on GPS, of course.
Right.
L1 and L3.
Well, they're not slightly different; they're significantly different. So
yeah, 1.5 and 1.29 or 1.26.
Yeah, so you can get you can do total electron content.
Right, but I'm wondering. I mean, if would I'm just trying to think here. So here's a hypothetical question. I remember hearing a long time ago that it was illegal to transmit more than one signal in the same amateur band, but nowadays, like club stations and field day and all that, you're definitely doing that. So would you be violating the 2.8 kilohertz rule if you?
I've been wondering that exact question. I don't know.
And would it help even if it was fine? Would it help you? I mean, if you had 2 whisper signals, just lockstep, like 100 kilohertz apart, whatever, on 40 meters, would that be legal? It probably would, and more or less, moreover, would that help you? Could you use that in some sort of auto correlation sort of means to a degree? I mean, you know when the things start. To take his viewpoint, you know when the transmissions start and end. I mean, and you shift frequency and sync with each other. They're the same frequency, just the same modulation, just shifted differently. I mean, you could bash them back together and get some information about phase relative between the two. I mean, I guess you could do that, but would it help?
I have to think about that.
Yeah. I mean, I've told Rob a number of times that the best way to do this would be a Part 5 transmission, because I've seen the application. It's like, do whatever the hell you want, just don't interfere with anybody. I mean,
That's right.
You can write your own rules.
Yeah, that's a loose definition of don't interfere.
That's what it comes.
They want to know that you know what you're doing, though.
Do no harm.
Yeah, yeah. Well, yeah.
Is Part 5 what the experimental transmitters, the ionosons, come under?
Yeah.
Yeah. Also the high frequency trading carriers, the clicky ones they use nowadays. You probably noticed those.
Oh yeah, the 50 kilowatt ones. Yeah.
Well, I checked. I when they first appeared, I checked them, and the resting carrier is 20 or 30 dB lower than the amplitude of the pulse that I think they used to initiate the a priori transaction. I think they're just using, and that's actually two pulses, millisecond apart on those.
Where do you hear these things? I keep hearing about them, but I don't know if I've actually.
They're just above the 40-meter band and below they're above the 40-meter band. No, they're around 6.9 and around 14. They're just above the 20-meter band, and they're just below the 31-meter shortwave band. And they have massively strong pulses. If I can find one in a moment, I'll bring one up. But anyway,
There seems to be a lot of garbage around 6.8. I've noticed that.
Yeah.
A lot of pirates.
Yes. Speaking of garbage, I've been getting a lot of garbage just above 15 megahertz. I get a lot of interference to WWV where I am.
It's probably radio. It's probably
not
radio
there all the time. It's on and off.
Radio Havana Cube has transmitters that are god awful. So if you find the garbage, very often I've seen this covering ham bands. You tune in Radio Havana Cube as some of their programs. You find the garbage matches the modulation.
Well, this is swept frequency from about 15 megahertz up like 200 kilohertz.
Oh, the wave profilers?
I don't know what it is.
Those things?
I guess so.
Those are wave profilers. Those are a commercial product you can just buy.
Oh, are you talking about Kodar?
Yes. They
shouldn't be right on top of WWV though.
Oh, well, maybe there's someone else.
This is one that it starts at 5 megahertz. So if I'm getting the interference, if I go LSB, I can get rid of it.
Oh, okay.
Interestingly,
right
only upper sideband relative to WWV.
I'm looking for the high frequency triggers right now. I don't see any active at this moment, but
yeah.
The markets are probably all closed.
Stock market's closed.
Right.
Oh dear.
But
these guys.
But yeah, the other thing I've heard similar to that is that I hear it on all the web SDRs, mostly in the Western U.S. But it sounds like and it's actually a frequency sweep, and I'll hear it on 160 and 80 meters in the middle of the daytime. So it is domestic over a wide area. But I have heard that in the past at Mountain Home Air Force Base near Boise, they had a chirp-based over-the-horizon radar running, and I don't know if it's that or not. It seems awfully low frequency because you hear it on the really low bands. But anyway.
Well, I think it's about time to QRT here.
Sounds like it.
But we've got some very interesting stuff to work with here.
Yeah.
Simply a matter of modulation.
Just simply a matter of modulation, yeah. Yeah,
well, talking about using broadcast stations. We actually hosted a system that MIT Haystack had installed using FM broadcast as a passive radar.
For meteors?
Hmm?
For meteors?
For all sorts of things. Meteors, ionosphere, and
Airplanes.
planes.
Yes. Yeah,
it was partially funded by DARPA. And I asked, oh, what's that application? He said, I can't tell you about it. And I said, I know what it is because I've heard it. Being an FMDXer, you can tell when there's a plane, when the signal reflecting off of an airplane.
The so-called Kraken WebSDR, or the Kerberos, there's a bit of kerfuffle about them maybe being in violation of ITAR stuff.
Right.
But
I'd like to get a copy of the code for that.
It's on, well, it's mostly on GitHub, isn't it?
Well, the direction finding, but what you're talking about is they needed to take the had to take the passive radar code down.
Oh, I think that was archived elsewhere. I haven't looked.
Okay.
But outside the US, I mean, Phil can tell you all about code.
Yeah, as I say, this is known technology. I mean, again, UHA developed this with RTL SDRs a long time ago.
Yeah.
That was one of his first articles, was how to make a passive radar out of these things.
Right.
So, and like I say, as an FMDXer, we know what it sounds like when the signal's bouncing off of an airplane. And the frequency is probably low enough that it doesn't get absorbed that well by stealth fighters. So that's the problem.
Right.
Anyway.
All right. Well,
thank you.
It's way past my bedtime.
73 off. Yeah,
Yep.
East Coast, it's almost 11.
Yep. See ya.
Later.
Right. All right. Don't have much else here. Okay. Who is actually recording this?
I don't know. Would it be Dave, KV0S?
I don't know.
I can't tell.
I don't think there's
So it says recording.
Yeah, it do, and it has to be somebody who's still here, I think. And unless maybe it runs automatically nowadays when the host leaves or the person who started it leaves. But it would probably have been, well, let's see, I guess who's the host? Could be come on. Stop that. I don't see anybody marked as host. Oh well. Anyway, maybe I'll wonder why one of these meetings again later. So appreciate what you do, Phil. It's even though I've kind of, for the time being, I've given up documenting K9Q radio on my website.
Well, that's really something I ought to be doing.
Well,
I'd
rather it be out of date than it not being worked on. So, yeah. Let's see. But I haven't really delved into it enough to have any questions for you, because I think I think either you're working on or have already done a lot of the little bits of feature creep that I asked for over the past year or so.
Yeah. The main thing I've been working on lately is using the status stream that I now put out on the data channels as well as the status channels.
Oh, okay, yeah. Rob was saying something about that.
Yeah, like my voting system was one of the first uses I made of it.
Voting from multiple receivers?
Well, multiple, here in Southern California, one very large linked repeater network called the PAPA system. And the idea is I can tell it all the channels that it's transmitting on, and then I'll just pick the best one to listen to.
Oh, okay. You doing triangle noise or or are you doing using the SNR for the voting?
Oh, SNR. I mean, I'm using the
Okay.
SNR that I emit on the SATA stream.
Oh, okay. And you're measuring that at the trough of the modulation, or are you just
No,
measuring?
I compute SNR. I have been computing SNR for a long time from first principles.
You're just taking the minimum and maximum values over in a sliding window, more or less.
What do you mean?
I mean the mixum. I mean miximum and I mean the SNR based. I mean instantaneous SNR would be hard to do. So I'm presuming an SNR would have to be done went over a period of time,
Well,
right?
it's done over every frame, every
It's
20
also
milliseconds.
FM signals. He's
What's
also
that?
working with FM
It's
signals.
FM. You actually have two SNR computations going on FM. There's the main one that goes for all channels where I just look at the energy in the channel compared to the energy density outside.
Right.
And the other one for specifically FM that I use to actually control the squelch is I do the moments of the amplitudes.
Okay. Okay. All right. Yeah.
In other words, the average amplitude of the signal should be constant, and any change in that's got to be noise.
Right. Okay. Yeah.
Right.
All right.
So the mean and the
Okay.
variance of the amplitude tell me what it is. It's not totally trivial because it gives you a chi-square distribution. There's a formula you got to iterate to get to an actual SNR, but I found out how to do that.
Okay. Yeah. I had to crack a similar nut like that with similar with very limited bandwidth restrictions, and I added the FM to the damn it, what's it called? The MCHF transceiver years ago.
CHF.
Yeah, it's a standalone using an ARM M4 Cortex SDR with waterfall and all that. It's your typical INQ based software defined radio.
Yeah.
It was developed in about 2011, 2012, I guess.
Oh, all right, a while ago.
Yeah, and it was unusable, and I picked it up, and my goal was to make it a respectable transceiver by adding things like AGC and good filters and property modulation and everything else like that, and I
Well, stuff
pretty
I've
much
done
got
too.
and I pretty much got sick of the side of it after about 2.5 years. Being
Yeah.
about the only developer, then it's like, I did what I wanted to do, so I went away. But the last thing I did though was adding FM and getting a decent FM squelch when all you have is 24 kilohertz bandwidth and very limited processing available to you
Yeah.
is interesting.
You know, the thing I've noticed about SDRs, one thing I've learned about SDRs is that everybody thinks when they first start out is the signal processing that is the hard part. No, the signal processing is the easy part. It's all the control plane stuff, the metadata. That's the hard part.
Oh, yeah.
Especially when you've got 100 channels and you're trying to, I mean, that's where all my work is.
Right. Yeah. Okay. Yeah, I years ago in '09, I built a voting system, synchronous and voting system we have here in Utah, but it's all analog, and it simply looks at the total amount of energy on two otherwise identical audio streams, and the one with the more energy
It's
is
the
not the
voter
good
one.
one.
Yeah. That's
Yes.
one of the old classic
Yes.
network repeater voting schemes, although it requires that you set the levels exactly right.
Yeah, and that wasn't a big problem. In the analog world, if you're careful, that's not a problem. I haven't touched the damn thing for 5 years, and it hasn't drifted. So
Yeah.
I don't want to mess with it. I got it working, and I'm leaving it alone. So
I thought about doing that myself, using that scheme myself here, but then it requires all the repeater levels be matched, and I figured, might as well do it right.
Well, I mean, so I was worried about that. I've actually built two synchronous systems, and the audio I discovered oddly enough that unless you're even in an overlap area, as long as you pick the correct phase out of 180 degrees, and as long as the audio is pretty much the same and the levels are the same, there's hardly there isn't as much interference as you think there is. like for the company I used to work for, we had 3 overlapping systems in Boise. And when you were right in the middle where you could hear all 3 transmitters, you just moved the radio a few feet in any direction and could hear a different transmitter. And the way you could tell is the courtesy beep when somebody unkeyed was different for each transmitter, so you could tell which one you were listening to. It didn't seem to matter a whole hell of a lot. The only thing I had to be careful with was the PL tone transmitted by all of the ones for the tone squelch. I did have to dial that in with within a few degrees. But the program audio itself, it seemed like if it was within a, do we use 0 or do we use a 180? And then had somebody in the middle and, oh, well, this one sounds better. And that was it. And that's what we did on this one too.
I'm not sure I understand what you're talking about. Are you listening on different frequencies or a common frequency?
Oh, common frequency. I mean, these are 2 transmitters on the same frequency.
Yeah.
And people talk about getting the audio delay exactly the same. It doesn't.
Oh, yeah.
It doesn't matter as much as people seem to think it does.
Well, in this network it does because they're digitally linked and there's no
okay.
between them. Yeah, they go.
Are the analog signals being transmitted, or are they digitally linked, or are they